Hello lovely people, what is up? Today we are solving Leetcode problem number 22, generate parentheses. So in this question we are given n pairs of parentheses and we have to write a function to generate all combinations of well-formed parentheses. So for example, the input is n, the output here is, as you can see, a set of parentheses. Here the essence of the question basically is to have three open and closed parentheses. If you can see in the first element of the output, all three are open and then all three are closed. In the second, two is open and one is closed. Again, one is open, one is closed, and the final one is closed. Like this, we have to generate all the possible parentheses for the given n integer. We also have to keep in mind that we cannot enter a closing parenthesis without opening that parenthesis. So here the key idea is to use backtracking. So at every step we have two choices: add an opening bracket or add a closing bracket. But there are a few rules that we have to follow. Basically it's very intuitive. We can add only opening bracket if open is smaller than n, and we can only add closing parenthesis if close is smaller than open. We stop when open equals to close equals to n. So we build the string step by step. We can start with an empty string and try adding open or close parentheses, and then we can backtrack. If invalid, we store the valid combinations. So if we take a look at the code, to store the current combination we use stack equals to an empty list. So let us imagine it as a building the string step by step. So that is why we are using stack, and then we initialize a result list to empty list, which is res equal to open square bracket and close square bracket. This stores the final valid results. Each valid combination gets added in this particular list. And then we define a recursive function, def backtrack, and the parameters are open n and close n. So open parentheses open n comma close n close parentheses and then colon. This is a helper function, recursive helper function. Open n is the number of opening parentheses used so far, and close n stores the number of closing parentheses used so far. And then we define the base case using an if condition. If open n is equal to close n equal to n. N is the given number of parentheses. So this condition becomes true only when we used all the opening and closing parentheses. So this string is complete and valid. So we do res dot append open brackets double quotes dot join in bracket stack close with the parentheses. So this, what it does is convert list to string, and this adds to results. That is, the separate charactered parentheses joins and combines to become one single string. And then we initialize a return state to stop this branch of recursion. And then to add an open parenthesis, we initialize another if statement. If open n smaller than n, we can add another. We are asking the question, can we add another open parenthesis only if we haven't used all n opens. That is what we are defining in this if statement. And then if it is true, stack dot append open parenthesis double quotes, and then again an open parenthesis double quotes and quotes. We add an open parenthesis to the current combination, and then we use our helper function backtrack of open n plus 1 comma close n. This helps us move forward and increase the open count. And then to undo the last step, that is the backtracking, to let us try other possibilities, we do stack dot pop. And then to add closing parenthesis, similar method we have to follow. So we check if we can add a closing parenthesis if close n is smaller than open n. So this statement becomes true only if we already have more open brackets than close brackets. And then we add the closing bracket using stack dot append open parentheses double quotes close parentheses double quotes and close the parentheses. And then to move forward and increase close count, we do backtrack of open n comma close n plus 1. And then to undo this step, backtracking again, stack dot pop. And then to start the recursion outside of our helper function, we do backtrack of 0 comma 0, and then we return result, return res. So the time complexity of this particular problem is O of nth Catalan number, which is O of 4 power n by under root of n. Why is it not just O of 2 power n? Because each step, it looks like we have two choices, add either opening or closing parentheses, but most of these combinations are invalid and we prune them early with using the if statement, so we don't explore all possibilities. So the number of valid parentheses string is Catalan number. Just look it up and you will get the formula. So the code is running without any errors. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye guys.